This is Gus Gonzalez, Seminar Extra Credit, Math 2000, GTID ending in odd number. We begin this problem by defining a linear dependence. So to do that, we define linear independence, which is the collection of vectors u1, u2, all the way up to up, which is just the final vector of that set, is linearly independent if the equation c1 times u1 plus c2 times u2 all the way to the end cp times up equals 0. You add all those up. If that equation only has one trivial solution where all the c's equal 0. If not, then it's linearly dependent. So if one of the c's does not equal 0, then it is linearly dependent. So the question is, suppose that T is a not one-to-one linear transformation that for some vectors v1, v2, all the way to vp, that the set of images, just T times that set of vectors, is linearly dependent. So this here is linearly dependent. We're trying to find out if this is also linearly dependent because of that. And so there exists some c1 tv1 plus c2 tv2 such that all of this equals 0. And the only solution for that is where c equals 0. All the c's equals 0. But because t is a linear transformation, you could take the t out. And then since it is one-to-one, the kernel of t in this equation here is 0. So the right side of this equation right here is equal to t of 0. So you set them equal to each other, take out t, and you find this. But the set of c's is non-trivial, so one of the c's does not equal 0. Since one of the c's does not equal 0, this is not true, and since this is not true, v1, v2, all the way to vp is linearly dependent, as well as t1, v1, tv2, tvp. So what this problem is trying to say is that if you perform a linear transformation on a set of vectors, it will not change its linear dependence or independence. So if you reflect a matrix, it will remain linearly independent or dependent, whatever it started as. Thank you.